This is free response number 4. This is the last of the free response review questions. We have Jamal is researching the characteristics of a car that might be useful in predicting the fuel consumption rate, FCR. That is the number of gallons of gasoline that the car requires to travel 100 miles under the conditions of typical city driving. The length of the car is one explanatory variable that can be used to predict FRR. Graph 1 is a scatter plot showing the lengths of 66 cars plotted along with the corresponding FCR. I think that's supposed to say FCR, not FFR. One point on the graph is labeled A. Jamal examined the scatter plot and determined that a linear model would be a reasonable way to express the relationship between FCR and length. A computer output from a linear regression is shown below with some of the information here. It's got R squared, pretty small. And here is your equation. The point A in the graph represents one car length at 175 inches, right about in the middle there, and an FCR of 5.88. Calculate and interpret the residual for the car relative to the least squares regression line. All right, here's what I got. Remember, residual is y minus y hat, actual minus predicted. So we have the actual value, 5.88. The predicted you can get by plugging in 175 into the equation, and you get about 4.925. So if you subtract that predicted from the actual, you get a residual of about 0.955. The interpretation part is that number is 0.955 units higher than the actual y value. So you would say the fuel consumption rate, FCR, was 0.955 gallon higher for the 175-inch car than predicted. Part B, Jamal knows that it's possible to predict a response variable using more than one explanatory variable. He wants to see if he can improve the original model by predicting FCR from length by including a second explanatory variable in addition to length. He is considering using engine size in liters or wheelbase in inches. Graph 2 is a scatter plot showing the engine size of the 66 cars plotted with the corresponding residuals from the regression of FCR on length. Graph 3 is a scatter plot showing the wheelbase of 66 cars plotted with the corresponding residuals from the regression of FCR on length. So you're going to notice that the residuals come from the original equation. So this value here, that distance, is going to have the same residual as wherever we're looking for over here. So it says part B in graph 2, the point labeled A corresponds to the same car whose point was labeled A in graph 1. Now, if you remember in graph 1, that residual was, I believe, 0.955, right? So what you're going to look for is on this graph, which is wheelbase, we're going to look for that same residual. So at 93, which is somewhere over here, I want that same residual, and it looks like right there, that's going to be my point. So indeed, that's going to have that same residual of 0.955 as we calculated in part A. And seeing that 93 is our wheelbase, you have it right there. Okay, part C, or part 2 of that problem. There is a point on graph 3 labeled B right there. And the question simply says, it is very close to the horizontal line at 0. What does that indicate about the FCR of the car represented by point B? And what I said here for at that particular wheelbase of what seems to be like 121, 122, something like that, the linear model with X as your length of car versus Y as your FCR does a good job predicting the fuel consumption, because if it's close to the horizontal line on the residual plot, it's pretty close to predicted. So you simply, in this case, want to comment on that. All right, thank you. That is our last free response. The next video will go over the multiple choice questions.